So I think it would be appropriate to just continue my progression in the NeetCode 150. I've done a lot of it, but I haven't touched it all, including DP. Haven't finished graphs yet. So maybe it would be appropriate to start with this first one that I haven't done. So, alright. Given a reference of a node in a connected undirect graph, return a deep copy or a clone of the graph. Each node in the graph contains a value and a list of its neighbors. For simplicity, each node's value is the same as the node's index, one indexed. For example, the first node with val equals 1, the second node with val equals 2, and so on. The graph is represented in the test case using an adjacency list. An adjacency list is a collected. Okay. The given node will always be the first node with val equals 1. You must return the copy of the given node as a reference to the cloned graph. Okay. So key things, return copy. Return copy. The value equals node's index, one index. What else? But the premise of the idea of what I'm doing is simple. So you have this graph, this original graph, and we're just trying to create a clone. We're just trying to create a clone and have the same undirected relationships. And at the end, we want to return this. We want to return the original. So I'm thinking we do a DFS where we start probably at the first one. And essentially every time we go through, so we start here and then we just go to its neighbors, we DFS through its neighbors, and by the end, either we've already seen it and we return, and we return the value, the node, or we haven't seen it, and by the end, we return the copy. All right. So what are we gonna need? So we're gonna have to keep track of what we've already seen before, and an important thing about this is that, so we're gonna go from, let's say we go from 1, we go from 1 and then 2 to 4, right? So we're in 1 and we add 2 and 4 to its neighbors. Okay, so now we're in 2. We need to add back 1 into 2's neighbors. It has to be exactly this one. It can't be, so we need to create, so I think for every time where we for every node we should also have a map where we map the node to its copy. So for example, so that way So we're here and we have like the OG to the to the copy. So then we go to 2. When we go to 2, when we want to add the neighbor, we can just reference right, because when we're at 2, we're looking at the original 2, and we see this. So we check this, and then we get the copy, and then in the 2, this is the copy that we're creating. And so same thing for okay, so let's think about what we have to do here. So in our DFS, we need to, so we say if, and the DFS is going to look something like this. It's going to look like def DFS, and then we're just going to pass in the current node. So let's say like current, and we'll check if current already in map, return clone via map, because we're gonna have a map that like original to clone, something like this. Original to clone equals map, and then so if current already in map, return clone via map, or else so we just walk through, or else we loop through neighbors we should probably add it first. Add, and then if not, or else add current, add the old one to the new one. So it'll look like if current in original to clone, return cur, and if we just like, it'll look like original clone. Else if we don't return, then we say original to clone cur equals node cur.val. So now we're creating the clone, right? And now I think we can loop in the neighbor in cur.neighbors. So now we're looping through the neighbors. For neighbor in cur.neighbors, what do we have to do? So we obviously are going to have to do this DFS neighbor, but what do we have to do first? For neighbor and neighbors, so right now we're at the point where so let's say we're in 1, right? So we have this map, and we checked if it's in the map. It's not, so we added it to the map. So 1 to 1, but obviously this one's the old, this one's the clone, this one's the original. So now we're in the, now we're going to here. All right, so now we're so now we're here. And we're not there yet. We're still checking the neighbor, right? We're like checking the neighbor. So for neighbor in cur.neighbors, we need to be able to add it to the clone list, right? So right now in the clone, right now we have this. We need to add both of them. So right now we're currently looking at neighbors, but we haven't added it yet. So we're looking at it, we haven't made that connection yet. So how do we do that? So for neighbor in cur.neighbors, so we're going to have to okay, so what I think we can do is we can say, since we're returning, every time we're returning the clone, right? So, yeah, that's how we, yeah. So since every time we're returning the clone, we're gonna say neighbor, we're gonna say original to clone dot cur dot neighbors dot append DFS neighbor. All right, because yeah, so that way we can guarantee that we're gonna return the clone, right? We're gonna go in here, we're gonna do everything, and then eventually either we've seen it before and like we've seen it before right away and we return it, or we go through all its neighbors and then we return the neighbor. Okay, so now then I think at the end we need to return this, right? Okay, So what are we missing? So we're going to create this. And now we're in 2. So then when we're in 2, right, now we're here. Right? Now we're here. So we're going to say if cur in original to clone, return that, which it's not. So we're going to create this. For neighbor in cur.neighbors, original to clone.neighbors, append DFS neighbor. Original to clone. Maybe we should say this first. If neighbor in original to clone, then we say original to clone dot neighbors dot append okay, geez, this is confusing. Okay, hold on. So now we're looking at, let's say we're at 2, we're checking 1. If 1, which is a neighbor of 2, is in original to clone, which it is, then we say original to clone cur. Alright, so we say 2, the clone of 2, dot neighbors dot append original to clone neighbor. Alright, so then now we're going to have this relationship. Because this one's coming later. This one's coming later. And then I guess we can just continue off that, right? We don't need to append yeah, we don't need to go through 1 again, I think. And at the end, okay, so that's when we go into 1, and now we go into 3. So 3, so if cur in original clone, which is not, we say original to clone cur equals node.val. Right now, I don't even know if we need this. Do we need this? Can we just return nothing? But anyways, so original to clone cur equals node cur.val. Alright, so now 3 is pointing to a new node 3. For neighbor in cur.neighbors, so for the neighbors of 3, we're going to do if neighbor in original to clone, which 2 is original to clone dot neighbors dot append. Okay, so now we're going to move on to 4. 4 is not, let's just go to 4, okay? 4. 3's already been added now, so we're gonna go to like 3, right? So 3 is going to be here. So now we're at 4. So it's obviously now, so we're going to add 4. We're going to add that relationship. And then for neighbor in cur.neighbors, so if neighbor in, so what are 4's neighbors? They're going to be 1 and 3. So if neighbor, so we're going to add, so by the way, I should probably do this again. So 3, it's going to create this relationship with 2, but the 2 has not come yet. So now we're at 4. So if neighbor in original clone, which 1 is, right, because we're looking at the neighbors of 4, original to clone dot neighbors dot append. Okay, so now we made this. And now we can finally actually go to the next one. Oh, wait. No, because we're not actually DFSing. Okay, wait, we don't even need this because the DFS, that's what we need this for. Because if it's already there, then we can just return that. Okay. So do we actually need anything else? So we're saying, okay, so now we're at 4. Okay, then we go to 1. It's already there, so we return that. So original to clone cur. So the clone of 4.neighbors.append 1. So we make that relationship. And now we go to the second one in 4. And that's 3. So we DFS 3. It's already in original to clone, so we return it. Okay, so now we have the relationship of 3. Okay, so now we're back to 3. We just looped to 2, and then we went into 4, right? And so after all this, we want to return original to clone cur. So now we finally have this. And then the same thing's gonna happen to 2. It's gonna finish the loop, right? So if we just do DFS, return DFS, and then we can say if not none, because here the node can be empty, right? If not none. If, we'll say if node is none, return that. Or else we return DFS DFS node. Alright. I think, unless I'm missing something, I think, okay. If node is none. If cur in alright, what are we actually going to have a none type here? Can we do that? Oh my god. Oh, wait, what? Okay. Wow. I thought for sure there's going to be a mistake. Wow. Okay, well, um, nice. So we did that, and we can check this off. I just noticed today that I didn't really practice this, and this was the section that I bombed my interview in, so I'll probably do this next, and maybe some DP soon. Um, but yeah, wow, okay. I did not expect that to run. Alright, so I forgot to mention the time and space complexity. So um, let's think. If you have, so let's say there's like these 4 nodes. I believe it's going to be the nodes plus vertices. So I think the time complexity should be I forget the notation, but like e plus v, and it may look like n from something like this, but let's say we have you know one one, 2, 3, 4. It may seem like it increases linearly, but so like this, but when you have more connections, then you're gonna have more edges, and that's gonna increase the time complexity for that. So that is the time complexity, and then the space complexity is, I think it's just O of n. Because so what are we creating? We're creating a new node for each we're creating a new node for each node, and then I guess within that node we're also creating a list of connection of we're creating a list of nodes, but those nodes are all pointing towards the same ones. So I guess I think that makes it O of like E, right? Like, or like N, because for each like new node, like for every connection, we're not taking up extra space, we're just referencing the previous one, I think. But alright, I just checked the complexity on LeetCode, and yeah, that is correct. Nice.